looking forward to come back once this lockdown is removed and we can start living our life again. Well, today I want to share with you some ideas that have been growing in our digital reality initiative within the framework of the Future Direction Committee. And we had a previous webinar that discussed in depth some social aspects of this issue, and you can see the reference there. So if you feel like hearing also the social implication of this part, you can take a look at that. I did that webinar together with Derry de Kerkhove, and he's the real specialist on social aspects. You may also want to take a look at the white paper. It's indicated there, that contains quite a bit of information that I'll be sharing with you today. And also, you might be interested, if you're working in the area of digital twins, that we have a call for papers for the Computer Internet magazine that is preparing a special issue on digital twins, and papers are due in November. So there's quite a bit of time if you're interested in that. Well, having said that, what I'm planning to do is first to set the scene, what we're talking about, then just a little bit discussion on what digital twins are for those of you that may not be familiar with the concept, and then we will expand on personal digital twin, and finally see their application to epidemics. You see there my email. You're more than welcome to send me emails and to discuss with me on these topics and others. So let's start by setting the scene. Well, of course, we are now in the midst of an epidemic, and the idea of the epidemic is something that has an exponential growth. It starts low and then all of a sudden grows up and explodes. And as a matter of fact, what we're seeing is that the epidemic is generating infection of many, many people. But actually, if we're looking closely, we are seeing not just a generation of infection, but other several waves. And if you're looking at the data coming in every day, you'll see that different countries have different waves coming up. Some waves is delayed with respect to others, some is more advanced, and so on. So actually infection in this current world are not happening as a focal point that generates the global infection, but actually there are several infection waves. And most of the time it's really difficult to intercept these infection waves at the very beginning because they are in a sort of way hidden. You really don't notice them. Now, what's happening is what you see on the right-hand side. We've got a number of green people. Those are the people that are potentially exposed to an epidemic, and they have a certain probability, P, of getting in touch with the person that is already infected, that is contagious. And actually, there's not just one person, but there are many persons that are infected at the same time. So this probability is shared among all the susceptible people, the exposed one, and the ones that are already infected. And of course, by becoming infected, they increase the number of people that are infected. So you have this kind of formula. Now, you have surely heard about this R0, or actually as the epidemic people call it, R0, that is the basic reproduction number. Now, this basic reproduction number is a function of what? Of the contacts that people have during their day, of the infectiousness of the bacteria, the virus, and on the duration period of through which a person is infectious. Actually, this number is a little bit of a figment of imagination. We have taken this number as something coming from the gods. Okay, so we have an R0 number, and some people are saying, oh, it's a 1.3, it's 2.0, and so on. But actually, this number by itself means really little, because it's just a figment of imagination. And the imagination is, what would happen if I put this bacteria or this virus into an environment with a certain number of people, and there's one people that is infected. Then I can measure how many people this single person is infecting, and then I can derive the R0. Unfortunately, the situation is not like that. It's much more complex. You've got a person that is infected, but this person is moving around and getting in touch with other people. Some people get infected. Some, for mysterious ways, are not infected. And over the time, the number of people that get infected from a single originating infectious person changes. So actually what we are much more interested in is not the basic reproduction number, but is the effective reproduction number. And this is actually what you are basically hearing from your government, from the healthcare institution. They are not talking about the basic reproduction number, but they are talking about the effective reproduction number. What is the current situation in terms of people that get infected from people that are already infected? And of course, if you have a R naught greater than 1, then you run into an epidemic. But if R naught is equal 1, exactly equal 1, then you have an endemic situation. On the other hand, if R naught is less than 1, then you have an episodic occurrence of this disease and this infection. Sometimes it fades away and then it pops up again and so on. Okay, so this is the basic thing. Now, by saying that if you have one person that can infect several persons, of course, this other person can infect more person and so on. And what you get is an exponential curve. But the exponential curve, as I mentioned before, are really difficult to intercept, particularly in the beginning, because they are flat, you see, you really don't see them. And this is what happened with most infection, including the current one, COVID-19. And now, as more and more data are becoming available, we start to understand that the virus was actually around the world already in November, as soon as November. Sometime is also saying it started in October. But yet nobody noticed it. And the reason why nobody's noticed it is because of the R naught that is really fickle. So sometime you have an infected person and this person is infecting other people. But some other time, that infected person is not infected anybody. So you might have had some people that was infected and they traveled from China, from which we understand the virus originated, through France. They took a plane, they went to France, and they were infectious. And that was in October. But actually, their infectivity was very low, probably. They had little chance of really unload the sufficient number of viruses, what is called the virus load, so that very few people got infected. And these very few people probably fade away and so on. So in the end, what you had is that nobody noticed this kind of thing that was already happening in October. And it took some time before this exponential cure really pick up steam. And at that point, of course, you started to notice. Now, it's very important to decrease these R's now, because the fact is that when you're decreasing it, you're decreasing the slope of growth. And just see the numbers. If you've got an R naught of 105 and you start with 21,000 people infected, after 2 months, you will get 400,000, which is a huge number, of course, but it's very little if you compare with the similar number of people infected, 21,000, but now with an R naught of 1.15, you will get 100 million people infected. So you see how important it is to try to reduce this R naught. Secondly, we get an exponential curve, and the sooner we can get into this curve and fix it, the better it is. Now, let me show you what's happening when you're manipulating this curve. Well, let's see. I'm here, I am at the point where I'm starting to take action. And you see, the sooner I take action and the less people are getting infected and are affected by the virus, get hospitalized, that's the gray curve, or even get die from the virus, that's the dark blue curve, you see? So this is a very important thing. The later I wait, and the more impactful is the thing. But also, it is very important to understand how can I decrease this R. You see, I'm still working on the 100-day of epidemics, but I'm only able to reduce the R to 0.88. It's below 1, so the epidemic is going to decrease, but the decrease is very slow. But if I manage to go to R68, you see how much faster the epidemic is going down. So you see, by playing with this number, you see, and of course, if you're going over 1, then it's increasing. So it's very, very important to try to intervene as soon as possible and try to decrease this R the sooner as possible. Okay, so now let's consider what is called usually the SRI factor. S stands for susceptible people. These are the green people, those people that have not been infected so far. Then you've got the red people that are the infected and contagious one, okay? It depends on the virus. Sometimes you've got a virus where people are infected, but they are not contagious. In the present situation of COVID-19, people that are infected are contagious, but they start to be contagious after basically 4 days. And then you've got the yellow entities that are people that we call removed. They are not part of the scheme anymore, so they don't figure in the number that we're using. And these are partly those that are dead and are outside of the box, and those that have recovered. Now, they do not count anymore. However, those that are recovered, again, depending on the kind of virus, may become again susceptible to reinfection. Some other viruses provide a lifetime immunity. It depends. We are not completely sure about COVID-19, what the situation actually is, okay? But this is what we have to consider: the susceptible, the contagious, and the removed. Now, to look at this R now, okay, it seems easy because you take the first square, you have one infected person and two susceptible persons. And then you see the end result and you see that all the three people are infected. So by looking at these two squares, you would say, okay, R now is equal to, because one person has infected two persons. However, if you take a closer look, it might happen that what actually was that this person infected this person. And then after a while, this person infected this person. So the result is exactly the same. You got three infected people. However, if this is the situation, R now is going to be 1 and not 2. So there's quite a difference. This is why it's so important to try to go at the micro scale and trying to understand how infection is reproducing. Just by looking at the big numbers, you don't get what is going on. Now, this exponential curve is just, again, some sort of figment of imagination, because it assumes that you have an infinite number, a limited number of people that can be affected. But as a matter of fact, the number of people is limited. So the maximum number that you can affect is the maximum population of the Earth. Actually, it's less than that, because what happened is that the shape of the curve is a logistic curve. So you've got the real number of infected people depend on exposed people, depends on the general probability of contact and the number of infected people. Now, this probability of contact in a logistic curve depends on the number of people that have already been infected, because as more and more people are becoming infected, then less and less people remains available to be infected. So you see, in the very beginning, you have this number of infected people is very low with respect to this one. So you basically have P. But as this number grows, this number tends to 1. And so you have 0. So this number is not going to grow anymore because of that. Now, the people that are getting infected and then that are removed, as I mentioned before, are not just the people that are no longer susceptible to become infected, are also people, those that have been recovered, that turn out to be a sort of shield, protecting other people. Because when you've got an infected person and that infected person is interacting with one of these people that are now immune, well, the virus load stops there, doesn't move on to another person, okay? So this acts as a shield. And actually, we have what is called the herd immunity. And this herd immunity is basically equivalent to 1 minus 1 on R0, on R naught, which means basically that in the current situation of our coronavirus, we estimate this herd immunity to be somewhere in between 66 to 75%. So when there will be a number of removed people equal to 66 to 75%, then the virus would seem to disappear. There will be no more infected person. Now, what are then the strategies for controlling epidemic? Well, the first clear one is bring R naught below 1, because we have seen that if we bring it below 1, it fades away. And you see in the picture, I'm starting to operate, I decrease the R1, and then it fades away. I can do this by increasing the number of people that are removed from the ensemble, from the set, through vaccination. I can do this by strict containment. I can do this by chasing the infectious one, doing tests, and chasing those that might have been in contact with the contagious people, so that I isolate them and strict containment again, till the point that I can eradicate the whole thing. And at this address here, you can see a very nice explanation of how this may work in through by looking at simulation. What are the different things? Another approach is trying to decrease the R naught to spread cases over a longer time. So you don't want to actually stop the epidemics once for all. Of course, it would be desirable, but it's also very difficult. But what you want to do is to be sure that the number of people that get infected can find appropriate curing through the healthcare system. So you want to make sure that the number of infected people that needs support stay below a certain number. And this number depends on the kind of facilities that you have available in that particular area. Now, you can do this by containment, that is decreasing the contact, the possible contact of susceptible people, and by decreasing the probability that the virus actually passes from one person to another. And you can do that through improved sanitation, through social distancing, and so on. See, in this diagram that you have on the right-hand side, we have been able to decrease, in simulation, of course, only, the R to just 0.8. There are still infectious people, you see, but they are spread around and they are not as stimulating the growth of the epidemics as if they were with an R over 1. Now, another strategy is to try to identify where are the attractors. Attractors are the places where people get the contagion. And usually one of these attractors is supposed to be the school, because kids are coming together, they touch each other, and they spread very fast the virus among themselves, then they go back home and they spread it again. So by closing down school, as an example, you are clearly blocking a certain type of attractor. By closing down certain kind of factories, you can also decrease that, and so on. And also, you can try to identify and block super spreaders. Who are the super spreaders? Well, those are the persons that, because of their profession, because of their way of living, are getting in touch with so many other people during the day that they are really a living bomb, an epidemic bomb. Now, if you identify this kind of person, then you can take action. As an example, we have seen in Italy that the super spreaders were doctors, medical doctors. And that's clear because they were in contact with the people, with the contagious people, they got the infection, and then they saw many other people. And so therefore they became a super spreader and spread the infection. So in this case, of course, you don't want to isolate a doctor because you want to use his competence, but what you want to do is to avoid that the doctor gets infected. So it's very, very important for this kind of super spreaders to make sure that they don't get infected, to provide all the protection needed, and to make sure that you're testing them every day so that as soon as you detect that one has become contagious, you stop that person from getting in contact with others. Now, another point is try to create island. Like to say, okay, I'm closing where Bangalore is from the neighboring states. By doing this, you are really having a strong effect, because you see on the right-hand side what is happening. Well, what is happening is that if you have 1,500 people that are contagious and you don't do anything, okay, well, they grow up to 6 billion people after a certain time. But if you split this 1,500 people into 3 sets of 500 and you isolate them, well, over the same period of time, they will infect 600 million people, which is still a huge number, but it's 10 times lower than the previous one. So enforcing isolation among islands is very, very important because you are decreasing that. The other thing is that what you want to do is to try, as the epidemic goes on, to acquire resources like respirators, support for breathing, and so on. And you want to balance the economic impact because you have these two things you want to take care. Healthcare on one side, but if you're stopping production, then the economy goes down, and you might win the battle, the fight against the virus, but you may lose completely the economic situation, which will lead again to some very, very dramatic impact on people's life. So you have to balance these various aspects. So now, having set in the scene, let's look into the digital twins. What are digital twins? Well, foremost, they are a digital model. So you see in the picture on the side, we have a car. And how did you make this car? Well, you started by designing the car using computer-aided design, and this created a digital model of the car. Then by using the data, you transported that, you send the digital model to the factory where you have the robots, and through use of computer-aided manufacturing, you created the car. And the car was created by inserting many sensors in the car that can relate, once the car is put on the market, all the information about the operation of the car. Now, here you see one single digital model of the generic car, but as soon as you're creating a single car, you're creating an instance of that model. So actually, when you are delivering the car, you have a digital twin that is exactly for this car. And you might have another car with a red paint. It has a completely different digital twin because it has operated in a different framework. Now, by using this IoT, this Internet of Things, this car, as it rolls on the road, can provide information, and this information makes sure that the digital model of this car remains up to date, mirrors the actual car. And this is what we call the digital shadow. So a digital model is a generic one, but what is going on at this exact time in that car is represented by its digital shadow, and the two are connected by the Internet of Things. Now, in addition to that, what you have is the fact that you can go back in this amount of data that you are building up here and go back and see what happened to this car over its operation time. And this is what we call digital thread. Now, to give you an example, this Tesla car has a digital twin, and the people of Tesla receive information about this car every night. Now, they were able to detect that a certain number of these cars were showing a certain vibration in a suspension. And they wonder why only a few number of cars were showing this kind of vibration. So what they did was to use the digital thread. And they went back for each of these instances of cars that were showing this kind of behavior to try to find out what they had in common. And what was discovered was the fact that these particular cars were assembled by a particular set of robots. And these robots were fixed on that particular day, and they created an imbalance. This one was fastening the screws on the bolts on this area much stronger than the other one. So what they did, once known the cause, they sent a message to all the workshop of Tesla, repairing car in Tesla, and said, okay, we've got this problem with these models. One of these models comes up to your shop, just fasten these bolts so that it levels out. So the driver didn't even notice this kind of thing because the vibration was very subtle, but Tesla was able to track and to intervene and fix it. Now, if we can do this kind of thing, to use this digital twin for objects like a car, can't we do that for ourselves? So create a personal digital twin, a digital copy of me that can represent my body, but also the environment where I'm living, my experiences, my expectation even my knowledge, my social circle, what are the people I'm interfacing with, the kind of business I'm running, and so on. Well, the answer is absolutely yes, we can. Now, You see this kind of graphics I put here on the right hand side. This is my data space. I just took some time in looking around and see how much data am I, how many data am I creating, and who is going to receive my data, and more important, what are these people doing with my data? Now you see there is areas where I'm generating data through entertainment. I watch something and the YouTube knows when I'm watching, for how long time I watch it, from where I watch it, on what kind of device I watch it. And then YouTube can create, and you see these, all these red dots that you see here, the brownish one are the information I'm providing, but the red dots are information that is being created by a particular company like YouTube. YouTube, through analyzing the data that I'm generating, can discover what kind of person am I, what do I like, and so it's going to provide me suggestion for things to do. It's going to discover what kind of devices I'm normally using, and is handing over from my device to another when I resume watching a clip or something. It can also get a feeling of what my social network is, because I may signal something as nice to my friends, and they're going to watch it. So they are not going just to know that I have some friend that I signal what I'm watching or what I like, but they're also going to understand my reputation with my friends. Because if they are seeing that my friends are picking up on my suggestion and seeing it, it means that I am a sort of leader in that area. I have a sort of leadership in that area. So you see here how many red dots are all around there. Well, all these red dots is information that we do not control, that have been created based on the data that I generated, but that are very, very useful to these companies. And what I would like is the possibility of getting those kind of information and using them. Now, it's important when they're thinking about an application of digital twin to actually capture what makes sense. And in the area of fighting an epidemic, what matters is where I am. I can do this through GPS, through Wi-Fi. I can spot nearby devices using Bluetooth, because this, of course, is information that may be useful, are data that may be useful to trace my movement and to track the evolution of an epidemic. So risk assessment can be managed or can be manipulated to decrease the R effective, the effective R. Of course, I can also be harvested through the personal digital twin, some bioparameters through apps that in this particular case can detect some specific signs. Like you see here, you've got the two apps that you may try on the web. There are basically, one is intercepting the coughing and detecting whether, through using your smartphone, and detecting whether the particular kind of cough may be an indication of a person affected by COVID. The other one, this one, is actually an application that stays in your phone, and as you talk, can detect by your voice, through your voice, whether there's a changing pattern that may be an indication that you may be affected by COVID. Now, again, this falls into the area of risk assessment, and it goes into the aim of decreasing the number of maximum people that are around. Because, of course, if you are told that you might have COVID, then you're going to get testing and you go into isolation if it's positive. Another area is, of course, the area of bioparameters. And these can be captured through add-ons, through the oximeter, through temperature measurement. There's a rumor that the next Apple Watch will have an embedded oximeter that can provide this kind of. You can measure temperature in many ways, even by creating in software, by creating a pattern of yourself, and you just calibrate that pattern to your normal temperature, and then you know that as your temperature increases, your heartbeat increase. So by measuring the heartbeat and by comparing this heartbeat to what you're doing at the moment, a temperature may be guessed. Of course, if you're running, it's just normal that your heartbeats are growing, are increasing intensity, but the accelerator inside your watch can detect that. So the application can work out this kind of thing and actually comes out to detect with certain probability your temperature. You can also work using all this data inside your smartphone, as an example, to perform onboard analytics, which means that basically all the information that is being collected, all the data that are being collected by various apps and by the environment and so on, can be analyzed within your smartphone. And that can provide you with indication whether you might be affected or not of that. But of course, in many cases, what you need to know is whether other people that are nearby to you, that might have been close to you, have been infected. In order to do that, you have to accept that you have to share also your data, not just getting other people's data, but also to be willing to share your data, because you might be one that has been infected. Now, one of the problems with the COVID is the fact that the latency, which is the period from the point of being infected to the point that you start to be contagious, is about 4 days. But the incubation period, which is the period from the time you're being infected to the time that there are some visible signs of infection, is 5-6 days, which means there's about 1 to 2 days where you do not show any symptoms, but you are already a source of contagion. So it's very important to find out ways to intercept this period where you do not know, you're not aware that you might be infected, but as a matter of fact, you might have been. And in order to do that, you need to understand and to be aware that you have been in touch, you have been in contact, close contact with some people that was contagious at that time. Now, you need to share data and to have this data being shared. Now, what could be a general framework for this? Well, first of all, you have all these personal digital twin you see indicated here. And as we have seen, they provide local analytics that tell you, by the time you're talking, there might be some problem with you. You better go and check. This is a warning for test requests, talking to the physical twin. That means you, okay? The personal digital twin talks to you and make you aware. Also, there's the possibility that once you are detecting that you are contagious, you might have a problem, then the personal digital twin may raise a red flag. This red flag should go where? Well, to the healthcare institution, not to the authority, but to the healthcare institution. The healthcare institution needs this kind of data because the healthcare institution then can go to other personal digital twins that have been in touch with you, okay, and say, hey, look, you might run the risk of getting the disease, the virus. So you better monitor yourself much closely. And just for precaution, just stay on for 2-3 days, okay, till a certain time has elapsed to the contagion possibility, so that if you're not showing any symptoms at all, okay, well, we want to be really sure, but anyhow, just to stay at home or do some testing after a few days and so on. And in case, of course, you result problematic, then let the healthcare institution work. Then the healthcare institution is actually performing a global analytics, because the healthcare institution, by having all this kind of data generated by personal digital twin, can understand what are the foci of the infection, where are the areas that are more susceptible of creating contagion or getting contagion or getting infected. And so they create this kind of segmentation. And then what they do, they talk to the authority. They don't need to say to the authority, you see, there is these people that has this COVID, or there is these people that has this kind of risk of being affected, okay? They just say, look, in this particular area, the probability of infection has raised over R now 1. Okay, maybe it's 1.5. So it's appropriate to take some countermeasure to decrease as soon as possible this R. Remember how important it is to decrease the R as soon as possible, okay? And so what is the authority doing? Well, the authority is creating the prescriptive analytics, the framework. And the framework is common to everybody, okay? So it's telling you got to stay home if you are in this particular situation, right? And in this case, it's telling this kind of thing to everybody, but it's only the personal digital twin that are in that particular situation that will tell the physical twin to you, basically that, hey, we've got to stay home, okay? Because now it's compulsory by the authority. So the authority still doesn't know that I am infected, okay? But still, they tell my personal digital twin, if you are, then you've got to stay home, okay? And this is something that is good there. Now, you might have that in some government may prescribe also the personal digital twin that in case their physical twin is not complying with the prescriptive analytics, then a signal, a red flag should be generated to the healthcare institution, say, hey, look, this guy was supposed to stay home, but is not staying home. And then it will be a matter of government, healthcare institution to decide what to do and how to take action against that particular guy. But you see, in this way, what we are doing, we are creating an architecture that basically, conceptually, is separating my data from the global data, but at the same time allows my data to be used in a neutral way so that more global analytics can be performed. Now, personal digital twin then can separate the personal visibility, what is my status, okay, from the global visibility. What is the status of my environment, okay? And this is very important because it creates what is called a value perception. Now I perceive the utility of this kind of thing. I know that I might have a risk, okay, of doing that, so I should be home, but I'm also perceiving that to walk in that particular area may put me at risk, okay? So, and this is separated from the regulatory enforcement environment, okay? This is a different kind of decision that should be taken. And you see, we have a sort of line separating the privacy concern from the societal concern. Societal needs require sharing. Personal needs requires privacy. And the personal digital twin can act as a separator between these two things, okay, depending what to do. So personal digital twin is crucial in creating awareness. Most of the time, it is not that people are foolish. They move around, they don't stay at home or something. It's just because they are aware. They are not aware that they can put themselves and others at risk. And you can't just say in general, okay, oh, you are at risk of becoming infectious because in Bangalore we have 26 cases. I mean, you got millions of people there. What is the probability one of these 26 cases is actually hitting me? Very, very low. It's actually more dangerous to cross the road probably and being and having an accident with a car or a motorbike. So people are digesting this kind of thing, okay? And this is why they are not complying. But if you can make them really aware, okay, then it's different. Now, the other thing is that once you have a personal digital twin in operation, what happens is that the personal digital twin can create a buffer area where privacy and sharing are managed within the personal digital twin. So remember, before we have one single line. We said either we have privacy or we have sharing. Actually, with the personal digital twin, as I shown in the architecture, you can do more. You can keep the privacy when privacy is not, where your data is not needed. And you can share when actually there's a need for share. So you're not going to share, you're not going to lose privacy if there's no need for that. This is what is really important with the personal digital twin. It's not like the government is saying, you need to give me your data, okay? But if you don't need my data, why would you have to have my data? Okay, oh, just in case. Well, this just in case now is managed by the personal digital twin. Okay, and the disclosure, this is also very important. The disclosure is based on a common framework. So it's equal to everybody. It's not that my data are shared and your data are not shared. No, if my data are shared and yours are not, it's because my data in that particular situation are important for the social benefit. If they are not important, there's no point in sharing them. The personal digital twin is also important because it can generate through internal artificial intelligence and to using artificial intelligence as a service. So that means going to the cloud. It can generate a number of information. It can make data out of data. It can make information emerge, like you are at risk of getting it. Your case is more specific because you're suffering from hypertension or other pathologies, you have got diabetes and so on. So actually, when I'm measuring the risk, it's not a generic risk, but the personal digital twin is measuring the risk on my body, okay? Why am I more at risk of another person that is by my side and that probably can leave without any particular precaution? Now, what we are aiming at with this architecture is the fact to have local awareness space, where on this local awareness space, we can share, and we may decide to share more, okay? Like I'm living in a condominium, in a building, and I want to share my data with my friends in the condominium and with the people in the condominium, because we want to be sure that by interacting one another, we are not running any risk, okay? So the probability of interacting with people in my condominium is much higher, or I do want to interact with them on a much frequent way. So I'm willing to share more data in that. So I create a local awareness space that separates from the global awareness space. This can also be very, very much useful in creating this island that I was mentioned before. You remember the importance of creating island. Well, the digital twin, personal digital twin can help in creating this kind of island, and this is very important. You see, this is an application of what we did in the city of Vo. It's a little village, well, village is about 30,000 people in Veneto, and they were one of the first being affected. The University of Padua set up a monitoring scheme based on this concept of digital twin, whereby they track the interaction of all the people. And you see, they have the non-susceptible people, the affected but removed, and the infected, currently infected. And by measuring the normal, okay, interaction, they have been able to sub-segment into smaller area and to contain very the epidemics. Actually, the epidemics run out of steam, and this area is completely without coronavirus. It's now already 2 weeks, and it was one of the most effective ones in Italy. Now, the other aspects that I need to mention is the impact of on economics. And you know that basically when we're talking about the economic impact, and we have to consider both the closing down time and the recovery time before the whole situation goes back to normal. And you usually say that you can have a V shape, a U shape, a W shape, or an L shape economy. And basically what it means that if you have a V shape, you start from the normal situation, you close down everything, and then you open up everything and you go back to where you were. If you have a U situation, you start closing down a little bit more, then you open up more and more. If you have a W situation, what happens is that you close down, then you open up because the economic impact is too strong, but then the epidemic starts again, so you have to close down, then you open up, you close down, and so on. And the L shape is really what you don't want to have, is the fact that you're closing down, and even when you are reopening, the economic does not improve. So basically, if you are aiming for a V shape kind of management, you've got to ask yourself, when can you stop the downturn, okay, that it recovers? Well, the problem here is that if you take too long to recover, then you get an L economy. It does not recover. And if you get a too short time, so you open up too short, then you get a W, because the epidemic will start, we pick up steam again, and you have to close it again, and you go back to this time and so on. Now, the personal digital twin in this area usually are limited to understand when is the real time, okay, to open up. However, if you're aiming for an W control, well, what you have basically is that you have the epidemic starting up, you intercept the fact that it's growing too much, you lock down. As you lock down, it goes down, then you start opening up and it takes up a little bit of steam, then you close down a little bit more, but less than before, then you open up and so on. So you create a shape of the economy that through subsequent decreasing waves of epidemics, you see, and increasing ways of opening, you can actually recover the situation, minimizing the economical impact. And personal digital twin can be used to simulate, segment, and monitor. Actually, what is usually aimed at is a U type of economic impact. Basically, what you want to do is a U type because you obtain a shorter time of recovery. You don't, it's not like a W that goes down, goes up again, down, and you get a longer time of recovery. A longer time of recovery and this closing and opening is a very, very bad perceptual effect, psychological effect on people. And you know, psychology is very important in business management. So you don't want to have this kind of W. And the other, at the same time, if you do this kind of thing and you start slowly, okay, implementing first very sharp, but then you slow down and then you keep monitoring, then the impact on the economy is lower. You see, it's lower. You don't have to go as deep as you go with the V, just in case. And when you open it up in a soft way so that you avoid this rebound of the epidemics. So the U shape is actually what you're aiming to in the control of an epidemic in an economic point of view. And personal digital twin can use to simulate, segment, monitor, and to provide contextualized awareness. You need to explain why in that area you're opening up shop, but in this area you don't, okay? It's not because you hate those people or you hated that particular business. You are motivating it, you are creating awareness. This is very important. Now, you might wonder, what is different in a personal digital twin from an app? Well, personal digital twin are much more sensitive because they are customized to the individual. So this is a very, very important thing. The second thing is that they can be tuned by the authority at micro level. So there's a framework that is general for everybody, but then you instantiate the framework on specific and macro level specific person. Thirdly, having a personal digital twin is a personal choice. So although the personal digital twin has to be tied to societal rules, it's something that you have, okay? And you understand, you can communicate with your personal digital twin and understand what kind of data are released and why they are released. And fourth is that the epidemic control is just a way to benefit from personal digital twin. There are many other ways we can benefit from personal digital twin. As an example, in our initiative, we are starting to work on cognitive digital twin, which are a specific subset of personal digital twin, looking at what kind of knowledge you know, how can you increase that knowledge, how can you make use of different knowledge out there. So this is a very interesting initiative that we have. If you're interested, please join. So all this is also, of course, as I mentioned, to do with privacy, and people seems to be very concerned in certain area about privacy. But this is the photo of Shoshana Zuboff, and she was the author of The Age of Surveillance Capitalism. So she's very vocal against the sharing of data, of personal data. However, when interviewed last month about this situation of coronavirus, she said that the apps to control the virus should be controlled by public institutions and be mandatory, as vaccines are. So basically the point is that even somebody who's very vocal for defending privacy in this current situation say, we need to use data, personal data, to fight these epidemics. And actually we used to use this data in a very, very precise way. The concept of island is very important. You see on the right-hand side this picture. That was the first implementation of the idea of island in epidemics control. That was back in 2 centuries ago, when the cholera struck London, and John Snow worked around and tried to find how is it that we have contagion here and far less here, and the contagion goes lower and lower as we move around, and finally discovered that the source of the contagion was the Broad Street well that was there. So the importance of micromanagement, okay, and the digital twin, personal digital can really do that, is very, very important. Now, you also have to understand that it's not technology, okay? Culture is playing a tremendous importance in epidemic control, societal factor, political systems. So the real factors in controlling epidemics is people behavior, people awareness, and social acceptability of measure. And this is what you can really achieve through the personal digital twin. You see, we are facing a multi-faced challenge. It involves health, but it also involves economy. And it's going to involve society because we are changing our culture, our way of doing things, and also doing business. Now, the personal digital twins can be of help because they provide you data ownership, your ownership of data, We do need, however, standardization, because you want to have this digital twin you develop in India to be able to connect with my digital twin when I come visit you, okay, so that you know whether I could be considered a suspicious guy or not. And we need a top-down approach, okay, with institution and government that really take the lead, particularly in standardization. And it's essential to involve people. That's very, very important because, as I said, it's a social aspect, it's a matter of trust. And you got to make people aware. You got to be transparent and you got to provide services because people will buy into this idea if they feel that they are getting services out of that. So that's my talk, okay? And you again, you see my mail there. So if you want to get in touch with me, please do. Now we can move to question, I guess.
Thank you. Very insightful session on PDTs and in the current times of pandemic, how does PDT really influence? So we have a couple of questions. So I would be reading out to you, and you may probably go one by one with the answers. The first question is, what are the security measures to be considered for PDTs?
Well, there are the usual measure, I would say, that refers to data, wherever you are sharing data, and the more so if these data are personal, have a personal value, then you need to be absolutely secure on who is doing this data, uh, what is going to be done with your data. So you need to be aware of this kind of thing. You also need to implement those measures that can make sure that your data are not hijacked by somebody else. They are not modified by somebody to provide a false representation of yourself. So hacking, it's very crucial in this area. You need to be sure that the framework that will be used by your personal digital twin is actually the certified framework provided by the government, is not something that has been hacked and being imposed on you. So I would say is the usual kind of measure that you want to have adopted. I would say in all that is personal data, particularly when we're talking about healthcare.
Thank you, Roberto, for that answer. So the next question is, suppose if government of any nation has launched any health apps to monitor the health conditions of its citizens, app be falling under a PDT?
Okay, there have been a number of countries that have implemented tracing and tracking apps. China for sure, South Korea, Taiwan, Singapore. These are all countries that have implemented that. Apps that are actually monitor your health. And I think that that was the substance of your question. So do we have an app that can monitor my health and raise red flags? Yes, we do. There are a few companies around the world. I know of two of them. One is a US company, and another one is a Swedish company that are providing you with this kind of apps. And you can have the very basic features that can be delivered if you are inputting your well-being. So you're saying, I feel fatigued, I didn't sleep tonight, I've got a cough, I'm sneezing, and all this kind of thing. So it's something that you are willing to input in the app. But these apps are also supporting a variety of biomedical sensors so that when you're using this app and you're willing to wear these wearable sensors, and part of this can be implemented through your smartphone itself, then the app automatically can detect some of your physiological parameters. It can detect your heartbeat, your breathing from your Apple Watch. It can detect your sneezing or coughing from the microphone in your phone, and so on. So yes, there are apps. I am for sure. I for sure know these two. They are quite. They are getting a tremendous impulse by this situation. So I've seen, and if you go on my blog, I mentioned this explicitly. They have seen a rise of 400% in this last month of adoption.
Thank you so much, Roberto. I guess that there would be many follow-up questions to your email as you have shared it with our participants. With this, we have also come to the end of Q&A. I do not see any more questions on the chat window. I would now request Punit sir, the guiding force for all of us in having this the series of webinar, chair of IEEE Bangalore section, to provide of thanks and the closing remarks. Punit sir.
Okay, and thanks everybody. I just want to mention that this talk was part of a work that we are doing at the Future Direction Committee, is on digital transformation, and there are a lot of implications on digital transformation brought forward by the epidemics. We have created a course consisting of 108 modules. This will be one of these that are available now to understand digital transformation and to execute it. So if you are interested in this, please get in touch with me, okay? And we can see how to deliver that.
Sure, definitely, Roberto. So I would now like to pass on for closing remarks to IEEE Bangalore section chair, the guiding force behind having all this webinar series. Punit sir, can you hear us?
Yeah, thank you,
Yeah,
Chingappa. I was
yeah,
disconnected in between, sorry.
yeah.
So first of all, on behalf of IEEE Bangalore section and on my own behalf, I would like to thank Roberto for agreeing to give this wonderful webinar on digital twins during COVID-19 situation. It was a really enlightening session, I will tell, as far as we are concerned, because so many new things we got to know about it. And we can see there is a huge participation, close to 150 people at one point of time attended. So that shows the interest among members as well as non-members of Bangalore section. And we would like to inform Roberto that Roberto, we are doing this webinar series since last 45 days, and every day we are having this webinar sessions, and we are really happy to tell that our members, they are getting benefited with multiple experts and with their multiple views, which is really helping us a lot in this pandemic situation. And we are honored to have you during this webinar session, and we are really thankful to you. Thank you very much. We will meet again at 8 o'clock. We are again have planned another webinar today, and we will be resuming the session from 8 o'clock again. Thank you.
Bye-bye.
Bye.
Bye-bye.